All right, I'd like to welcome everybody to the February 2025 DAS meeting. We got a few things on the agenda, and then Jeff will give his lovely talk about the Antikythera Mechanism. So first item, do we have any new members who'd like to introduce yourself? Anybody? I don't see anybody new. Okay, very good. And then next, Kim, you want to tell us about what you wanted to talk about? Which is the Messier Marathon?
Sure. Mount Cuba is actually going to be hosting on March 29th. We're going to be hosting a Messier Marathon. It's going to be running from 7 p.m. to 12 a.m. is going to be when guests will be allowed into the building. Easton Honecker is actually the one who put most of this together. There's about 5 U of D students that have offered to help, and then we have some others that are coming that are actually going to stay past the midnight hour and view all the way till the morning. They're going to try to get all 100 items in before that time frame. But in saying that, we have extended ourselves very thin since they're going to be here all night long. So we're looking for a few more volunteers who would be interested in helping out. So what's going to happen is from 7 p.m. till 10 p.m., we will have our members and non-members who have registered will be there to participate. And then at 10 o'clock, most of them will leave. Any members are going to be welcome to stay till midnight. So what we need help with is basically someone who can man the 11-inch telescopes up on the roof. The students they're going to be bouncing around. They have a Sarah viewing that night, so they're going to have people looking through in a library, looking at what they're viewing through Sarah. They're going to be doing imaging on the 24-inch because that's going to take a couple of them to do that. And then we'll have 2 11-inch telescopes set up. And then Greg Lee has offered to run the 4-inch that night. And might be nice for someone else to be there to help Greg. Give him a break. If he's going to be there till midnight, he may need someone to step in for him. So anyone else who's able to find some let me see. I'll tell you exactly what Easton says you need to be able to do. He needs somebody who is familiar with the Messier catalog and that can find things on the 4-inch with no electric guiding. So if you can find some deep sky objects without needing anything, and I know Greg can do that, but we're looking for someone else who might be experienced with a 4-inch. I know Rob said he's going to help out that night, so Rob could be one of those people. But if anyone else is interested in helping with the 11 inches out on the roof, and then possibly just fielding questions from the guests that are going to be there, we're probably. I know Dave also said he may be stopping in and bringing his Sea Star, so that will also be an option. But just if we have people from Mount Cuba and DAS who are, knowledgeable to be able to answer questions when the kids are busy doing all of their stuff. I say kids, they're adults, but to me, they're kids. Um, but if anyone else is interested in coming that evening, like I said, we need at least 2 more people who are comfortable using the 11-inch telescopes upstairs. And you can either email me or call me at the observatory and let me know if you're interested in helping out.
Good.
Any questions?
Anybody have any questions about that?
You want to repeat the date and times, Kim?
Yes, it is March 29th, and we would need assistance from 7 p.m. until 12 a.m. or at some part in between there. I mean, you don't have to stay the
That's Saturday?
It is a Saturday, yes.
Cool.
Answered your question.
And Kim, I know an email came out. Did you just send that to like a couple of officers, or I know I received one. I don't know.
I sent it to the Mount Cuba Associates.
Okay.
Because I usually do that because I know they're familiar with the equipment
Right.
at the observatory.
I was just gonna offer as a
know-
follow-up, if you would want to shoot something to ourgroups.io. If nothing else, it gives people an easy email address that they can reply to.
Yeah, absolutely. I can do
So,
that.
Yep. There you go.
cool.
Anybody else?
And again, you're welcome. I know that Jeff and Rob have also made mention that, you know, they could we could use some of the DAS equipment that evening. The only reason Easton and I were concerned to be a problem is not just because we're trying to man so many things, and if we have people between two spaces and he kind of has a plan set out on how he wants to do it. But I'm sure it's not a problem. People would like to view no matter what. I mean, if you guys had something set up and people were coming and going, they could stop and look. So I don't want to discourage that because, you know, but we want to keep what he's planning on the roof up there
Yeah.
separate, I guess. So,
Yep.
That's awesome.
but yeah.
That's great. I think it's awesome that Cuba's doing that. That's really cool.
Very cool.
All right, it's like I said, I will send an email so you guys have contact for me. And if you're interested, I'd be glad to have you.
Thank you very much, Kim.
Thanks,
All
Ken.
right, thank you guys. Have a good night.
All right, next item on the agenda. Really quickly, I'm running the election for 2025. That's for board members at large. There are 3 positions for board members at large, and basically they would serve for 2 years, starting in July and ending in the following July. Basically, the job entails just showing up for board meetings, representing the club, making your voice heard, voting in our votes, and, you know, having discussions with us. There's not any strict requirements like for the officer positions. It's like just generally representing the club. So I think they're very honorable positions, and we have some great people serving in there now. But if somebody else is interested, by all means, you should run. It would be really exciting to get some people involved. So I will be posting information in the Focus over the next couple months. If you read the Focus in February, you would have seen that already. And I'll post it again in the subsequent couple months. If you let me know prior to the April Focus deadline, I can post your name in the Focus with the other candidates and say who's running. If you want to give me a little blurb about why you'd like to run and a little bit about you, that could make it even better. So I'll be reaching out to the 3 current board members at large, seeing if they still want to do it and getting such a blurb from them to put in the Focus. But if anyone else is interested in running, just let me know before the April Focus deadline and we can get it in there. The last chance you can choose to run in the election would be at the April DAS meeting. So I'll open it up to the floor, just like this right now, and give you a last chance if you're interested. But you got plenty of time until then. I would recommend sending me an email all about it. So, you know, definitely volunteer. We'll have some fun on board. Next item, Greg, you wanted a couple moments to talk about an event, I think it was. Oh, up here.
Sorry, coming up before our next meeting is the lunar eclipse.
You want
Yeah, maybe. I'll see if I can do
You
that.
probably have already heard of. Some of the announcements that you see talk about Thursday night, the 13th and 14th, they may be referring to the part of the eclipse that is the penumbral part. It's so dim that I never even bother paying attention to the timing on that. So this is the timing for the actual between first and last contact is 3.5 hours plus. The part that happens, the totality is they're about an hour's worth. So this is early morning stuff. And don't get confused like I have done in the past. If it says March 14th, it's not the night of March 14th. It's the early morning of March 14th. Wow. Thursday night, staying up late into the evening. Now, I was working with, we're getting a new relationship being built here with Brandywine Creek State Park. And I had an indication early on that we would be invited to be up there on Hawkwatch Hill where we've been before for other events. Turns out security issues are not gonna permit that to happen. They still wanted to have something going on that day, so they're gonna have one of these pop-up events that there will be early evening observing of stars, and they're going to talk a little bit about the eclipse that will happen after midnight. But after they do that, they're going to send everybody away from the nice observing site and say, you can't stay here and see it. But they wanted me to come out anyway and do some star, and I try to explain to them, you know, so lunar eclipses happen at full moon. It's not a stargazing night. But they're learning as we educate them as we go along. But there'll be other events coming up at Brandywine Creek State Park. I can talk to the people out at New Garden Township Park and see if we can get permission to be out there. We've been out there for other things. It's a nice, wide open site. So watch the announcements. More than likely, we'll get permission to be out there for that. So
good.
Cold weather, 3 hours. You don't want to come out that night. You can step out in your driveway. The full moon happens, of course, moon coming up when sun's going down. So midnight puts it on the meridian. It'll be high in the sky. Step out if you've got a couple of hours. If you don't want to come out for a long cold time, just go out in your yard and it should be high enough to see from almost anywhere.
Cool. Thank you very much. All right, next, Bob, you wanted to say something about these?
We're still in the dues collecting process for 2025. We're getting close to the end of it. So far, we've had 135 members renew their dues for this year. So thank you for renewing. If you haven't renewed yet, you still can renew. I sent you an email last night if you're on that list, and you can pay here at these types of meetings, or pay PayPal, or send you a check in the mail. The email says how to do that. But again, we're wrapping up the process. Thank you for everyone who's renewed.
Okay, thank you. Next item on the list, Bill, you want to talk about the ATC?
Sure. Okay, I'm not even sure if they can see me on
Maybe I'll put it this way.
Oh, there you go.
So the astrophotography special interest group meeting for the month is going to be this coming Saturday, 1 p.m. on Zoom. And we'll undoubtedly talk a little bit about photographing the eclipse and probably telescope collimation as well. So hopefully we can make that.
Nice, thank you.
Oh, and I should mention too, the announcement will go out midweek on the groups.io to let you know.
All right, cool, thank you. Next, Mary, did you want to talk about the book club?
Yes, can you hear me?
Yes.
Okay. The book club will meet on next Thursday, February the 27th at 7 p.m. via Zoom. And we will be discussing Chasing the Stars, How the Astronomers of Observatory Hill Transformed Our Understanding of the Universe by James Lattice and Kelly Tyrell. And it's a wonderful history of the Washburn Observatory, which is a research observatory like Mount Cuba with a storied history. Jim Lattice is an astronomer and a science historian, and Kelly Tyrell is a seasoned science journalist with ties to Delaware. She was a science journalist for the News Journal and for the Philadelphia Inquirer and at University of Delaware. So she's very excited about joining Delawareans to discuss the book that she's co-authored with Jim Lattice. We will also be joined by members of the Madison Astronomical Society, their home astronomical society. They're celebrating their 90th anniversary this year. We'll also have with us for our discussion Trudy Bell. And many of you may know she's a well-published science journalist and science historian who's about to publish a book about the history of observatories in the United States. It's going to be a landmark book. And she'll be bringing with her Phil Shoemaker, who's an expert on the Cincinnati Observatory. And we'll have a few other special guests. I don't want to keep everyone, but you're all welcome to join. Kelly and Jim will be giving about a 40-minute presentation at the top of our meeting, a little bit different for the book club. So even if you've not read the book, you can attend the meeting and sit through the presentation, and it would be a unique opportunity for you to learn more about this important American observatory and their history. Thank you.
Thank you very much. Thank you. And finally, Jim Kirshen, you want to tell us about outreach activity?
Yes, we've had some very successful outreach events earlier this month. On the 1st, Saturday, February the 1st, we had a night of planets at the Delaware Museum of Nature and Science. And that was seen by an overflow crowd of 155. Oh yes, there was a lot of folks there. That was a great event. On Tuesday, February 3rd, we collaborated with the Wilmington Friends School at a private residence in Chadds Ford, Pennsylvania, just over the border into Pennsylvania at a private residence for an astronomy night lab. That was a very interesting night. And on Friday, February 7th, we collaborated with the Newark Parks and Recreation Department at the Newark Reservoir for their Cocoa and Constellations outreach event. That was attended by a crowd of about 55, not all at once. They kind of came in dribs and drabs, but everybody had a good time. And I want to thank everyone who came out to share their telescope and their knowledge with the attendees. You just never know when you're going to inspire a young mind. So thank you very much.
That's awesome.
Very nice. Bravo. All right, so next, Jeff, if you want to come up and tell us about the Antikythera mechanism.
No, I
Or
don't.
Antikythera. However you say it.
There's how to pronounce it.
Well, all
Let me
right.
know if you need anything.
So let me think. How do I want to do this? Oh, wait. We are sharing the screen, right?
Not yet. You have to share button.
Okay.
Yeah.
Let's see. We don't need this. We don't need this. We'll do this, and then we'll just do, I forget what's the, like this.
Yeah, there you go.
Oh, accept.
You want to pin the DAF. There we go.
Okay. Yeah, so appreciate those that have braved the cold to come out here tonight. And obviously, and thanks to everyone who joined us online. This is a subject that I started to gain some interest in a bunch of years ago. I'm trying to figure out a way to introduce this without ruining all the surprises. But I'm an engineer for money, for a day job as an engineer, and I do astronomy for fun. And this mechanism, Antikythera, so as a preface, Antikythera, I'm not sure how it's pronounced. I'll probably flip-flop between the two. It really struck a chord with me that kind of resonated with both my interest in astronomy and engineering, as you know, I hope you guys will appreciate as we go through the talk. And again, if I said anything more, I would just be stepping over my feet. So let's just jump into it. So ancient wisdom, the Antikythera Mechanism. So to set the time and place, time about 70 BC. And that's important. Just to kind of set the stage, because that feels kind of a long time ago and kind of abstract. Cleopatra is born around that time. Julius Caesar's doing his thing. And Hipparchus recently died. And that will also become important as it ties into this topic. And that's what computers looked like at the time. So, I mean, we're talking a long time ago.
You don't even remember that.
Right.
I still have one of those.
Okay, put it up channel 3.
So the place, and again, the place is important here. So we're looking at a map of the Mediterranean, and we're going to hone in on the area between Greece and Crete. Greece, mainland, and then the island of Crete is down here. So if we zoom in on this section here, I'm not sure how well the eyes show up, but there's an island here called Kythera, don't know, but something like that, which is right here. And if we zoom in a little bit further, there's this island called Antikythera. Now, for us astronomers, we can make the map. We have the star Antares, which basically means not Mars. Well, the island of Antikythera is basically just not Kythera. Okay, so it's a little island next to a little bit of a bigger island off of mainland Greece, Antikythera. There was a shipwreck.
Pretty dramatic.
Yeah. So, a little bit of time travel here. We're going to jump to the year 1900. A little more recent. So, and again, I apologize to anyone who is Greek. I am going to botch all these words and names, so I will apologize in advance. But a Captain Dimitrios Kondos was setting sail from the island of Simi. And he and his crew were a group of sponge divers. So, and that's actually them. I don't know which one is Dimitrios, but you can pick. Doesn't matter. Yeah, right. And one of his crew, a diver named Ilias Stadiatis, he was deciding around, and you can see they're, sponge diving here. And while he was diving, he discovered a shipwreck. Okay, nothing too crazy. I'm sure there's tons of those. But there were many kind of typical objects that you might find on a shipwreck, including some bronze statues, some marble statues, coins, pottery, jewelry, the usual stuff. Except there was something else that was kind of curious. Some strange device. And as you can see, this is an actual artifact of the piece that was discovered. It simultaneously looks like something and looks like nothing at the same time, but the keen eye noticed that there was something going on here. This was not just some rock or piece of rubble, but there was something about it that caught their interest and their attention. Again, the year about 1900. So a closer examination is actually when this rock broke apart, and archaeologist Valerios Stais noticed that the device contained a gear. And he suspected that it might be an astronomical clock. And the two things that really resonated or I thought was fascinating about this and what caught a lot of people's interest, as this talk evolves, we'll understand it a little bit better, but the knowledge of astronomy that this device represents, big spoiler surprise, it is an astronomical clock, but also the fabrication and manufacturing that represented. Scientists of today did not realize that people of that time had this technology. So it was really, really curious, but they really didn't know what they had at that point. And so they put it into storage on the National Museum of Archaeology in Athens, and it was pretty much ignored for several decades. They knew they had something, they really didn't know what it was. It was obviously severely compromised, you know, in order to really try to make heads or tails of it. But, you know, they put it in a museum. So that was cool. Again, the year 1900. So we've gone from about 70 BC, zooming forward till about 1900. And then we're going to bump into about 50 years later. Some renewed interest in 1951, a British science historian and Yale University professor, Derek de Sola Price, he began to study the device a little bit further. Again, I don't know the history of what got him connected to it. Again, it had been sitting in this museum for 50 years, but for some reason, he decided to study it a little bit more. Jump 20 further years, he partnered up with a Greek nuclear physicist, Charalampous Karakalos, and they started to, technology is going to be a big theme of this talk. So 1970, X-ray technology, and then even some gamma ray technology, they were able to study this mechanism in a way that had never been possible before. So there's Derek, and there's Karakalos. Karakalos, there we go. And they actually put their findings into a report, 1974. De Sola Price published his findings in a paper, Transactions of the American Philosophical Society, titled Gears from the Greeks, the Antikythera Mechanism, a Calendar Computer. So I kind of call this a cosmic jigsaw puzzle. It was really, really interesting how this whole thing evolved. So over time, I mean, this thing was a 2,000-year-old device that had been sitting at the bottom of the water, you know, bottom of the ocean for all this time. And so it was not in great shape. So over time, this device split into 82 fragments. And that made it a little bit even more difficult to try to put it all together and figure out what this was. So it's been very difficult to figure out still what this device was for. But little by little, different clues started to emerge. And it really became a kind of an archaeological exercise for them to, or forensic exercise even, for them to make sense of what this was. So an early clue. This is the museum display. As I mentioned, all these fragments, I think if I remember correctly, they just for scientific and research purposes would name and label all the pieces just so people could intelligently talk about them instead of like this little bit and that little bit. So the three main fragments, fragments A, B, and C, kind of gave a little bit of an insight or gave the first insights as to what this really was. And there's the X-ray of fragment A superimposed. Definitely some gears. And we'll take a look now at a schematic that they were able to reconstruct out of these X-ray scans. So, little math warning here. If your eyes start to glaze, just bear with us. We'll get out of it pretty soon. There are a couple of moments in the talk where we get a little bit more technical, but only a few moments. So, looking at the mechanism, and I've color-coded it accordingly, green, orange, yellow, and white. The yellow gear had 64 teeth. The orangish gear was a compound gear that had 48 teeth and then 38 teeth. The green gear, a compound gear that had 127 and 24 teeth. And then the white gear had 32 teeth. Okay, well, that's great. So what? Well, doing some basic gear math, as you can see, it's this, however you want to think about it, it is the green gear, well, sorry, the yellow gear driving the green gear. So if you do the ratios of the meshing teeth, you've got the 64 teeth of the yellow gear driving the 38 teeth of the red gear, which is then coupled to the 48 teeth of the lower part of the red gear, driving the 24 teeth of the green gear, blah, 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 blah. You multiply that all out and you get a ratio of 254 to 19. Okay, great. Those are just some numbers, who cares? But someone was astute enough to recognize that that number rang a bell. So what this means, for people that don't subscribe to Gear Teeth Monthly Enthusiast magazine, that when the yellow gear would turn 19 times, the gray gear would turn 254 times. And again, that started to kind of make the light bulbs go off. 19 to 254. What might that mean? So, what is so special about this ratio, 19 to 254? Well, let's take a look at something. On the left, I have the Sun-Earth system. So the sun in the center with the Earth orbiting around it. And on the right, I have the Earth-Moon system where the moon is going to be orbiting around the Earth. I'm going to play an animation of these two orbits happening simultaneously, and we're going to track the solar years against the lunar months. And let's see what happens. Okay, so we made 1 year, 365 days, and there were 13 point change lunar months. Okay, 1 solar year to 13.4-ish lunar months. So every time the Earth goes around the sun once, the moon goes around the Earth, again, about 13 1/3 times. Play that one more time, just to... All right. So now we're going to do it a little bit differently. We're going to go a couple of years. In this case, same idea though. But in this case, we're going to go 19 years. And in 19 years, or 19 times the Earth going around the sun, the moon has gone around the Earth 254 times. Wait a minute. Those numbers sound familiar. So 19 solar years equates to 254 lunar months. This is what we call the metonic cycle, because they sync up at that point. That's the key thing, that both have come back to their sort of default 12 o'clock original orientation. And so we can look at the new moon calendar, 23. I kind of skip ahead every couple of years. And it's, oh boy, I could have done a better job with this. I've highlighted a couple of events. A second. I think something's not showing up right here. I'm just going to skip over this. So some additional clues. So some further clues as to what this device really did and its full functionality came from some careful and creative interpretation of some inscriptions. So there's some other fragments they could puzzle piece together, and they could note that there were some, you know, very broken up, but nonetheless some inscriptions that they could, you know, try to get a little bit of a sense from. I believe, God, it's been a while since I put it. I think that means it's all Greek to me. So, based on this new information. This discovery cemented the fact that this device was absolutely an astronomical calculator. And the Solar Price actually put a recreated model that had not been sitting under the water for 2,000 years to kind of recreate the mechanism as he understood it at that point. The story continues. So we're still talking here 1970s. Fast forward a little further, another wave of resurgence in interest in the mid-2000s. What have we gained in the mid-2000s? I don't know. Some extra free time, but also computer modeling, advanced computer technology, different things like that. And really, with computers and their advancement by the mid-2000s, tremendous power put in the hands of common people. So several groups have studied this mechanism more carefully, and different physical and computer models have been built to demonstrate what this device actually could do. And we're going to, again, for the rest of this talk, just really start to dig down into this a little bit deeper. These are a couple of models, recreations that we'll be digging into a little bit more. So the current state, and again, it was sort of almost uncanny as I started to dig and gain interest in this thing. It almost seemed like the world was, I don't want to say following along, but Scientific American, I believe this is January 2022, their front page article, Wonder of the Ancient World, New Insights Decipher the Antikythera Mechanism's Ingenious Astronomical Calculators. Archaeology, scientists have revealed new details about the complex gearing of the Antikythera of Tony Freeth from the University College of London. So kind of cool. So now we'll start to dig in and show you some of its features. This mechanism really revealed to the folks that have been studying it of recent how the peoples from 2,000 plus years ago had great understanding of how the various celestial bodies moved through the sky. And an important thing to keep in mind here, I think this is an important fact that helps gain an extra appreciation for everything I'm going to share for the rest of this presentation. They had a tremendous understanding of how things move through the sky. They had a mechanism that could predict or calculate these motions, and all of that with a geocentric view of the universe. Mm-hmm. So the key is noting that their geocentric view of the solar system did not allow them to understand why they moved, but nonetheless, they had a really, really solid understanding on the motion itself. So we're going to break this mechanism down bit by bit. There was a front face and a back face. The front face, the easier one, the planetarium. This showed the motion of the sun, the moon's phases, and the 5 planets known by the ancients. Okay, and I have a couple of videos because I found some little videos that explain some of this stuff way better than I ever could. So here is a little zoom in on the moon portion of the mechanism. So you can see, and again, understand, we'll get more into the mechanism of this thing, that it shows not only the location of the moon, but its phase as well. And this was a physical mechanism. And this is obviously a computer rendering of a modern interpretation of what the device looked like. But the actual device did this all with gears and all this other kind of stuff. So pretty neat. So they could predict the moon, position, and phases. Oh, we'll look at it one more time. Then on that same face, we had the planets. And again, a little video here that kind of highlights what this was all about. And we'll just watch. So also showing some insight of what we think the full mechanism actually looked like. So they had plates with pointers for the main planets, or the planets that were known at the time, as well as the sun, and of course the moon with its phases. So it was a series of dials or pointers that would move around. Oh, you're jumping ahead of Slider too. But very observant. That's cool. So pretty amazing. Again, the more I dug into this, the more amazing it became. Well, okay, well, all right. So, as Sid was very cool to point out, let's take a closer look at these planets. And as I play this animation, pay extra careful attention to Venus here. And let's see what happens. And again, remember, all this with a geocentric view of the universe. So, pretty cool. So, this is a talk that I do for Mount Cuba Public. So most folks know what retrograde motion is, but, maybe not everybody. So retrograde motion is the appearance of the planets as they're going through the sky to, for a brief moment, they appear to be moving backwards. And again, with the geocentric model of the universe, they had all kinds of crazy ideas and theories for why that might have happened. With the heliocentric view of the solar system, the retrograde motion becomes a lot more explainable, and it's simply a matter of perspective. The planet is not actually moving backwards. It just simply appears to do so because of the relative motion of the Earth with, again, the retrograde planet. And this is a little animation that kind of shows it. And it's simply because the Earth and any retrograde planet are in motion relative to each other and relative to the sun. And so you get a kind of a complex motion. If that little schematic doesn't show it, there's actually a really cool video that I found that explains retrograde motion. And it's very dramatic, so.
In the sky, stars rise and set due to the rotation of Earth. However, the pattern of stars that is seen in the sky, how far apart a pair of stars are seen from each other, stays the same over timescales of thousands of years. However, planets move in the sky relative to the pattern of background stars. They change their position in the sky from night to night. The term planet originates from the Greek word for wanderer. This phenomenon can't really be seen on any given night, but if you note the location of a planet relative to the background stars, and note its location again several nights later, you will see that it has moved. This could be seen if you took a series of photos every night for a month with a chosen star highest in the sky and laid them over the top of each other. Planets typically move eastward, the direction of increasing right ascension, which we know today is due to their revolution around the sun. Note that a planet still rises in the east and sets in the west on any given night due to the rotation of Earth. This video will focus on a variation of that motion known as retrograde motion. This apparent motion concerns the planet slowing in its eastward motion, stopping, moving westward for a while, and stopping again before continuing on its eastward journey. For superior planets, those that orbit the sun further out than Earth, and the only planets that will be discussed in this video, this effectively creates a loop in the sky. 2,000 years ago, the Greek astronomer Ptolemy explained retrograde motion with a geocentric system of wheels within wheels, kind of like the kids' drawing game Spirograph. It was believed that Earth was at the center of everything, and that a planet moved on a circular path called an epicycle, the center of which moved on a larger circle called the deferent. This allowed the existence of retrograde loops to be explained, although in a complicated way. We know today that this explanation was completely wrong. In the 1500s, Copernicus explained retrograde motion with a far more simple heliocentric theory that was largely correct. Retrograde motion was simply a perspective effect caused when Earth passes a slower moving outer planet that makes the planet appear to be moving backwards relative to the background stars. Thus, retrograde motion occurs over the time when the Sun, Earth, and planet are aligned and the planet is described as being at opposition, opposite the Sun in the sky. This is why retrograde motion is referred to as apparent retrograde motion by many. Nothing is changing in the planet's motion, and retrograde motion occurs as a natural perspective effect. Let's look at a demonstration for teaching retrograde motion. It consists of the Sun at the center in red, Earth, and a superior planet in a circular orbit around it. Here, a white rod connects Earth and the superior planet similar to Mars and represents the perspective, pointing to the location where Mars would be seen in the sky from Earth. East is counterclockwise around this circle. A system of circular gears controls the positions of Earth and Mars and their rates of motion. A hand crank allows the demonstrator to advance Earth and Mars while the gears ensure appropriate relative rates. Note that an arrow illustrates the direction of apparent motion in the sky, and we have placed background stars around the edge where we will see the apparent position of Mars. We start our demonstration several months before Mars reaches opposition. Remember that Earth is moving faster than Mars and will shortly overtake it. The rod connecting Earth to Mars points to Mars's apparent position in the sky. As we turn the crank slowly to advance time, Mars is initially moving eastwards. We have now reached the point where Mars's eastward motion appears to stop, the beginning of retrograde motion. Note that Mars is now moving westward. Mars reaches opposition at the middle of retrograde motion. We have now reached the point where Mars's westward motion appears to cease, the end of retrograde motion. As we continue to advance time, Mars resumes its normal eastward motion relative to the stars. Note that this effect is entirely due to perspective. Nothing changed in the motion of Mars or Earth.
So again, the ancients didn't understand or didn't correctly understand why retrograde motion was happening. I still find it amazing that they knew the retrograde was occurring. You know, careful note taking, and we always say they had the benefit of, you know, clearer skies and also no distractions from social media and other, you know, modern.
No light pollution.
No light pollution is a biggie. So again, to state the thing that a lot of folks know, but again, tying back to the mechanism, planets don't follow circular orbits around the sun. They actually follow elliptical orbits. And we have these terms, perihelion, when it's close to the sun. And the solstices are all tied to or connected to this elliptical orbit. Again, nothing too new or amazing for us. However, oh, sorry, one more little preface here. This shows various objects. These are not trying to represent any planets or anything. It's just showing different elliptical orbits going from green to pink with increasing eccentricity. So the red is very, very circular, and it becomes less and less circular, more elliptical as we go down to the pink. And the key points here is with an elliptical orbit, the speed of the planet varies along the elliptical orbit. And in addition, when the planet is further from the Earth, it appears to move more slowly than when it's closer to the Earth. Again, I think it was it Isaac Newton was the one who was finally able to explain, or Kepler. So, but we're talking what, 1700s. But yet, the Antikythera mechanism suggests, demonstrates that back then they knew about this. Now, a little preface here. The Antikythera mechanism. I showed you some photos of what the surviving device looked like. And it really became an interesting combination of archaeology, forensics, whatever you want to call it. And forensics in terms of, even like paleontology, I think they find some little tiny bone and they make some big story about it. Oh, yeah. I think we're good. So keep that in mind. Another little video of suggesting how these planetary eccentric orbits were captured in the Antikythera mechanism just with the gears. And again, this one gets a little technical. If it goes over your head, just bear with us.
There was a portion of the mechanism called the planetarium. The planetarium is actually largely missing from the recovered fragment, but there are clear indications of its existence from both the inscriptions on the device as well as broken off attachment points on the main drive wheel. Its purpose was to model the motion of the various celestial objects known at the time. The makers of the Antikythera mechanism would have had astronomical observations from Babylon to inform their understanding of these celestial motions. And for modern imaging of the main drive wheel, we've met some dimensional information. Research on the device in the last 25 years has had a heavy focus on matching these two things together. With these locations and quantity of pivots and pillars, what gears and linkages could have been used to produce the desired motion? Now, I am far from a historian and do not have access to the full scan data of the device, so I consider this an opportunity to follow in the steps of the maker, but using modern orbital data in place of the Babylonian observations to derive the gearing and geometry from scratch. To get started, we'll take a look at the night sky, where we can see a whole host of bright objects, primarily stars. Some are planets, but right now we don't know which ones. Let's focus in on an arbitrary point in the sky for a closer look. Nothing is readily apparent now, but when we compare it to the next day, things get interesting. A few objects have shifted, and if we come back night after night, they all seem to be moving along a common line, generally in one direction, but occasionally reversing back during short retrograde periods. If we record the position along that line of Mercury, for example, we get a curve that looks like this, a generally increasing mean motion with a periodic motion layered on top of it. The planet appears to be going in reverse, but the periodic motion temporarily overwhelms the mean motion. When we add on the other planets, Venus, Mars, Jupiter, and Saturn, we see they have slower mean motions and longer periodic motions by comparison. We're going to need to measure three things from each of these curves to design a gear train that can reproduce them. The average slope, which represents the mean motion, the period of the periodic motion, and the amplitude of the periodic motion. There's one subtle alteration in this gear, and that is to change from sidereal to synodic angle. This means that rather than measuring the angle relative to the stars, we measure it relative to the sun. We'll see why later on in the video. We can get the mean motion with a simple trend line, and once we subtract that out, we can measure the amplitude of the trended data very easily. The period is the more interesting one. If we use the power of modern computing to do this with a Fourier transform, we can isolate the main signal that we're seeing. However, notice the secondary peaks that indicate additional signals. This is actually a clue that the solar system is heliocentric. It comes from resonance primarily to the eccentricity of Earth and the planet in question's orbit. Far too subtle to have been detected by manual observation, but a fun Easter egg in the data. We can repeat it for each planet and then condense it down to this table of values. You can immediately tell that Mercury and Venus are not like the other three planets. They have no synodic rate at all. In other words, even though they are wandering back and forth a bit around the sun, all three move together as a sort of loose groove through the sky. Both planets stay bounded within a certain angle from the sun, their periodic amplitude. Okay, now let's actually start coding, at least conceptually. For the movement of interior planets, we can use a crank and slider mechanism like this one. It has the benefit of not only producing the needed oscillating motion, but it also moves asymmetrically in a way that oddly matches what we were just observing. More on that later. The length of the arm is determined to produce the right periodic amplitude, and the gear set powering it is chosen to produce the right period. All of the planets in my recreation of the mechanism, as well as the original to the best of our knowledge, are powered from the 1 year per rotation main drive gear. Here are the target gear ratios to translate from that 1 year rotation to the oscillation period of each planet, as well as the gears I ended up choosing. And here they are. This is part of the lower planetarium assembly. Mercury on the bottom has an 82 to 26 gear ratio to take that 1 year down to its 115-day period. And Venus, shown on the right, has a 62 to 99 gear ratio to go up to its 584-day period. I went ahead and added the colored pointers that will end up on the front dial for reference. When I manually rotate the input gears, you can see that asymmetric oscillation really come to life. In the full machine, these input gears are actually fixed and the drive gear is rotating. This is known as epicyclic gearing. I teased a little bit that there's a reason the motion is fairly accurate, and it has to do with the pattern seen in mechanical computers like this. It's not uncommon for the best way to generate an accurate output to be a scale model of a system that follows the same physical behavior. If I take this geometry, preserving everything at scale, and overlay it over a map of the solar system, we can see it's just a scale model of the orbits from the point of view of Earth. To finish the planetarium, we still have to handle our remaining 3 planets, Mars, Jupiter, and Saturn. Recall that these have a mean synodic rate, so they are constantly moving in a direction in addition to their back and forth movement. For these, we're going to use a very clever set of 4 gears to handle their motion. The purple gear is our 1 year per rotation input, and the yellow gear is our output that needs to be constantly rotating for our mean motion, but also lagging and surging with the periodic motion. The mean motion is pretty straightforward. We just need to choose gears that give us the correct speed of the yellow gear. This is a normal compound gear train where the output angle is linearly proportional to the input angle. Offsetting these gears produces a more interesting behavior, however. While the pin on the green gear is still moving at a constant speed relative to the green pivot, its speed is now variable relative to the orange gear, which produces that oscillating motion we're looking for. Tweaking the offset sets the right amplitude, and we'll need the output to be coaxial to the input, but that's everything to it. All 3 planets use this arrangement, with offsets and gear ratios selected to match their mean and periodic motion variables. If this seems a bit complex for such an ancient device, consider that we actually see this arrangement on the solar year to lunar month gear train discussed earlier. In the TT scan of fragment A, here's the pin and the slot of the stacked gears, and here's my reproduction of it. That's the offset pivot, and if I give it a manual spin, you can see the top gear speeding up and slowing down a bit. This one even has a variable phase shift for apsidal precession, but thankfully we don't need that in the planetarium. And here's the portion of the planetarium with the superior planets. The 3 input gears are fixed together at the top, each driving their respective pin gears. The pins extend down to the slot gears below, which then rotate the output gears in their center that transmit their motion up through coaxial tubes to the pointers. And that concludes the process for determining the planetarium.
So a lot of heavy stuff in there. And as I said, I emphasized the archaeology and forensics. He saw some little clues in there. The slots from the CT scans. Now, were there certain liberties taken or over extrapolations? Again, I have to leave that to everyone's interpretation. I guess I'd like to stay convinced that the 2 are linked.
It was a portion of...
So that's the front face, again, the planetarium. So now we flip the device over and we look at the rear face. This is where things get really, really interesting. These are the various cycles. And the rear face had 2 sort of main dials, top and bottom. And we'll take a peek at each one of those individually. So the rear top face, again, a lot of information here. I mean, you see there's the main dial, and then there's these 2 smaller dials inside, but the main large dial is that metonic cycle, full circle where we kind of started towards the beginning of the talk. It's the spiral of 235 synodic months in that 19-year cycle. So this metonic cycle is this 19-year cycle that after 19 years, which coincides with 235 lunar months, where everything kind of sinks back up again. So again, but if you want to look at the Earth, Sun, Moon system, they're on this metonic cycle again of 19 years. And so this was tracking that metonic cycle. Inside, we had the Calippic cycle. And I'm not super versed in all these things, but the Calippic cycle is simply a period of 4 metonic cycles. Okay? So keeping track of that. I'm not sure the significance of the Calippic cycle, but if we jump over here, is maybe a little bit of a hint, because this was a circle. And again, they understood this stuff, a combination of studying the gears and the gear ratios, but also the little bit of the inscriptions that survived. So this little inset gear is actually the Pan-Hellenic Games cycle, which was the cycle between the Olympics, the Nemean and Isthmian, the Pythian. And so this was the cycle of the games that the Greeks engaged in. Obviously, the one famous and surviving being the Olympics. So this mechanism could help them keep track of where they were in the Pan-Hellenic Games cycle. Pretty interesting. And again, all just driven through gears, lots and lots of gears. To go to the next level of pretty amazing, the rear bottom face, we have the Saros cycle, which is a period of 223 synodic months. And inset in there, the Exiligmos cycle, which is 3 Saros cycles. Okay, what is all this stuff? Again, I'm not going to get into a whole lot of detail because this starts to get even a little bit fuzzy for me, but this is all stuff to help predict solar and lunar eclipses. Again, pretty amazing that they even had enough data. I struggle with that one, because to be able to predict solar eclipses would take such a tremendous amount of data. And the amazing thing about solar eclipses is, as we've all seen over the past bunch of years, they occur regularly, but not in any given spot on Earth. So kind of interesting that they were able to put all that together.
But they do come back to that same pattern of sloping northwest.
Exactly.
Southeast, but shifted a little westward the number I've forgotten.
Yeah. Well, I think it's something in here. Yeah. As I said, this is where I get a little fuzzier, but it's still cool stuff. And just kind of scratching the surface with all this stuff, but pretty amazing. So this was an eclipse calculator.
So who lived long enough to keep traveling?
What's it say?
Who lived long?
Well, it's not it's records.
Yeah.
I mean, they were amazing record keepers, and not just them. I mean, they were certainly leaning on the Babylonians, and
that's where I was leading with the eclipses. If they're getting data from different places, it'd be all over the place.
Yeah.
You'd have to get data from a single location.
Yeah.
Get that much better.
Pretty amazing, though. So, putting it all together, again, a modern interpretation. Again, a little bit of forensics, maybe some creative liberties here, but this is a modern computer rendering of what someone's best stab at what the full mechanism likely looked like. So again, starting from the fragments. This is really exploring the full gear train of the mechanism. So again, just some amazing clockwork from, over 2,000 years ago. Truly remarkable. The only thing is, I don't think this accounted for daylight savings time. They were smarter than us in that way.
We started doing that at Stonehenge.
Right.
So the sunrise and the sunset.
That's right.
What about the metals? From
Brass and bronze,
brass and
Yeah.
bronze?
something like that. Yeah.
Yeah.
Yeah, absolutely.
So Jeff, I mean, you mentioned the market, right?
Yeah.
So, trade,
Yeah.
it's not, we have no records of him doing these calculations the way they were doing it in that video.
Yeah.
They don't, right?
I-
They were engineering this by visual records, not calculating it
Correct.
and then making.
Right. And that's the key point that I think, again, a mistake on their part almost makes it more impressive for me. They did not understand. Again, they had a geocentric view of the universe. And so they did not obviously have the physics right, but had enough data that they were able to numerically, or whatever you want to call it in modern terms, reconstruct this stuff. Yeah. The fact that they were wrong about the fundamental mechanism almost makes it more impressive to me, honestly.
It's that much more complicated.
Yeah, exactly.
So this was the feat of engineering.
Yes,
Much more than, okay.
absolutely.
But based on some amazing observations.
Yes, exactly.
We gotta remember, this kind of info, they treated this as power.
Yes.
A bunch of the ancient cultures used their predictive powers to gain power in the culture. This was their power.
So we've kind of taken a time travel through this talk, starting, 100-ish BC, and then we fast forwarded to 1900 when the mechanism was discovered, 1950s when De Salle started to take some interest, 1970s they started doing X-ray and CT to understand the mechanism a little bit better. And then the mid 2000s when people started using computer modeling and things. And then we jumped back all the way until just a handful of years ago. And this just absolutely blew my mind as I'm in the midst of learning all this stuff. A fairly mediocre sequel comes out, Indiana Jones and the Dial of Destiny, where if you have very careful and creative eyes and you look in the background, or if you've actually seen the movie, this whole movie was about Indy seeking out this, what they called was the Antikythera Mechanism. Now, yeah, who saw the movie?
Yeah, I saw the movie.
So in the movie, the Antikythera is some type of time travel device. I would say it was better than the Crystal Skulls or whatever, but was still not a very, very good movie. And especially nothing like the original ones. But nonetheless, yeah, kind of hokey that they were using this Antikythera mechanism as a time travel machine. But hey, it shed some light on the Antikythera mechanism, something that I had been studying for a couple of years up to this point that I assumed almost no one else in the world had even heard of. And then bang, there it is in Indiana Jones. So first of all, thank you. And obviously I would feel absolutely compelled to cite. Obviously you saw a lot of videos and things that I did not put together. So I want to make sure I give credit where credit is due. For those of you that kind of picked up, again, the couple of aspects of this that I find so interesting, the one that got me the most engaged, a YouTube channel called Click Spring. And this guy is a watchmaker that first brought this Antikythera to my attention because he has a series of videos where he's recreating building the Antikythera and kind of sort of trying to say in the spirit of the fabrication techniques that they had at the time. He's an amazing craftsperson and creates truly beautiful work. And so for anyone that has an interest in fabrication or metalworking or machining, Click Spring was the source that, again, first got me intrigued by this. So again, I don't have all the details. I'm not sure that anybody does, but it sure is mighty curious. So again, thanks again for all your attention. I'll try to answer questions. Bill.
Yeah, it seems to me that the gearing here would not be something that just one person suddenly decided I'm going to here. There probably was a group or a certain number of people at the time who used gears for other purposes.
Sure.
So the question would be, you know, is there any other evidence of similar gearing used for timing mechanisms or anything else?
Yeah, there's another device that actually this Click Spring guy has been making, and I forget what it's called. The best answer that I can give to your question is I don't know. Again, I feel like I've really even just barely scratched the surface of this. I obviously, if other folks have better answers, again, this is
They went digital around the birth of Christ.
yes, right, exactly. Yeah, I mean, I think this did not necessarily like completely shatter modern people's conception of like their ability to like make mechanisms or whatever. I think just the sophistication of this is really changed our idea of what they were capable of at the time. I mean, somewhere in my notes, and again, it's been a little while, I forget how many gears that this is, and they're all intermeshed together, which, you know, just requires an amazing amount. Now, granted, this wasn't mass production, so they're probably sitting there and filing them down to fit, you know, perfectly together. But yeah, it's a great question, Bill. I don't have a great answer though, unfortunately. Yeah. Any other questions or comments?
One of the things I noticed when you're showing that it was, you know, 82 different pieces, a lot of small pieces.
Yeah.
Do we know if they brought up one chunk and things sort of fell apart from there, or if they were scooping all these
It's
pieces up from?
my understanding is kind of the former. Yeah.
So a lot of crumbled and.
Yeah. Yeah. I think in one of the earlier slides, I talked about how like it was, yeah, almost falling apart as they were trying to, you know, which is
1900, right?
yeah.
And sponge divers.
Yeah, exactly.
Just funny sponge.
Yeah.
Especially with the salt water. I mean, once you bring it into the air, you have to
Yeah.
do something to preserve it.
Yeah.
Yep.
Water too would have broken it down over years.
Yeah. Dave.
The other thing I would say, you know, when it comes to eclipses, especially solar eclipses, it doesn't mean that they were looking to actually observe a solar eclipse, okay? It was just predicting the fact that the moon would and the sun would be in the same place, okay? So I think you got to you know, break those two apart. They were thinking, oh, let's go look at a solar eclipse.
Right.
Where they were just looking at, okay, the orbits of these two things are going to be overlapping each other for whatever reason.
Right.
So they're on, you know, that's a thing you might want to consider with this whole thing, what they're trying to do when they're computing this.
Yeah.
They may not have been able to figure out that the eclipse is visible in this spot and not that spot.
Right.
And that took until the 1700s.
Yeah, to get maps and geography.
Where the actual path of the eclipse would be. I think what they were looking at here was
Cycles.
these cycles, these things.
That's it.
Yeah, was it. That was
Cycles. This whole thing is about all these different coincidental cycles. Yeah.
They were probably more concerned with lunar eclipse anyway, because that could be seen from a wide range of places.
Well, and some people have talked, I mean, Rob alluded to this, you know, imagine the power of the select few that could predict a lunar eclipse and, you know, the power that could, you know, hold over somebody. Yeah.
I see a lot of similarities between this and Stonehenge.
Yeah.
Back in the.
And what's people's current, when do we think that was built?
Oh, that was a lot earlier.
Yeah.
And of course, they didn't have the mechanical skills. But I read a book that came out in the 1970s. It was called Stonehenge Decoded.
Mm-hmm.
And it's where they went to Stonehenge, did all kinds of measurements and things. And then fed them into a computer, and they're saying, a computer in those days was a big, extremely big box, with punch cards and stuff like that. And they were actually able to work out a lot of the similar things that the Antikythera mechanism is showing.
Mhm.
Just incredible.
Yeah. Yeah, taking us all this time to be able to do what they were doing back then.
And somewhere at home, I do have a schematic of all that gearing in there, and it's just incredible.
Yeah. Yeah.
Well, the other thing too is all that gearing has to be integers.
Mm-hmm.
To get you can't do fractions.
Exactly.
So you have to come up with ratios. to
Right.
get you
Right.
These oddball.
Yeah, there's no 87.632 toothed gear.
Right.
And if anyone's interested, I actually just donated a bunch of similar books to Mount Cuba, their lending library, because they were just sitting on my shelf. I just took it in college in a course called astronomy. We studied a whole bunch of that stuff, and so I donated them like about a month ago, and put them on the shelf. So you can check them out.
Yeah, and actually another piece to this, my original intention, which we all know how intentions go, is talking about the various phases of interest in this. A handful of years ago, maybe it was 2 years ago, there were a couple of, I think it was two guys that worked together and created a set of a 3D printable, fully functional, complete model of the Antikythera. Up until then, in my poking and research, I had found a couple of people had made 3D printable versions of the Antikythera, but at that point they were either incomplete. Like I saw one that was just the planetarium, so just the front face, just. Or other examples that were the complete mechanism, but they were not functional. Well, again, I think it was about 2 years ago, in the midst of me starting to really dig into this stuff deeper, there was a group that actually put together a printable, complete and functional version that I was actually waiting to. So I got it. They're selling the plans, which I bought, and bought a 3D printer for the first time just for this reason. And my intention was to actually hold off on giving this talk until I had actually built one of these. But, I'm running into some problems with the printing. Let's just say, stay tuned. Eventually, I might be able to get it, and we'll actually be able to have a 3D printed, fully functional version of this thing, which, again, will just bring a whole different level of appreciation to it. That's not how they didn't have 3D printers back 2,000 years ago, but
The first part where you're talking about the multiplication to get the correct ratios, I've studied mechanical analog clocks and how they do that. Because, if you want to go from 1 second to a minute, you can't do a multiplication with a 1-tooth gear and a 60-tooth gear. It just doesn't work. So everything has to be done with a combination of compound gears.
yeah.
So I thought that was really interesting. As soon as I saw that, like, it's just like this box.
Yeah, absolutely. Yeah. And then again, if the forensics are correct, the fact that they were then using these slotted gears to mold in the eccentricities and stuff, just mind-blowing. Again, simultaneously, the fact that they knew those cycles well enough, but then were able to engineer the mechanism to reproduce it, 2,000 plus years ago.
You thought that with that technology, things would have shown up elsewhere, and things would have gotten advanced more.
Right.
So why did that happen?
There is certainly a lot of mystery, and I would be remiss to not acknowledge there may have been some liberties taken with this. Again, they had this fragments of rubble that they forensically, archaeologically put this story together. I think it's a compelling argument, but obviously we don't know for sure.
I think a big difference between our society now and then is that the people who made this kind of thing, they were few and far between. They were the best of the best.
Yep.
They were their top engineers and scientists. We're just some random group, we're Joe Schmo.
Right.
Anyone can see this stuff on the internet. We could buy a 3D printer and make it.
Right,
And they could not do that then.
right.
Something that always fascinates me, somewhat related to this, is what was lost in the Library of Alexandria.
Yeah,
That burned down. There are original Bible scrolls there apparently, and stuff dating back thousands of years that just gone in the fire.
yeah,
Assuming that these people were not as smart as we are today, but they
Yeah.
were. They just didn't have the tools to build the machines, but they were no less smart than we were. I know we have a habit of thinking, oh, they were backwards, but
no.
in a lot of ways, I think they were just as smart, if not smarter.
I was gonna add, if not smarter.
I think smarter because they didn't figure out that.
Right.
Yeah, exactly.
That's great.
Yeah, yeah,
Of course, they also had less.
Go 500 miles west or east.
right.
You know,
Well,
different
when you have a society that holds knowledge in that high of an esteem,
And you get.
yeah. Cool. I love the comments. Again, part of this was just, I'm not claiming to be the renowned expert. Yeah. Yeah, you really, again, I feel like this opens a million more questions than it answers, which is, yeah.
It says there.
Chinese guy.
Yeah.
That would be.
I just want to make sure I'm not, any questions or comments from online? Just want to make sure we're not, neglecting our online friends.
Yeah, Jeff, do you know anything about I don't know if the word is machining techniques, because they had to be pretty darn precise to be able to create gearing that was that precise, and their observational instruments and techniques too. They had to have extremely precise observations to be able to get all that right without depending on a whole lot of math.
Yeah. Well, I think they had, yes. I mean,
I've made wooden gears.
yeah.
And it's not that difficult to make precision gears with
Mhm.
just a file.
And Sheila, the answer is files.
Yeah.
Okay.
Yeah.
I like it. That's
And hours and hours and years and, of filing. And as I said, it's.
But who made the file?
Right, exactly.
Yeah, right.
You have to break yourself out of the modern mindset of like mass manufacturing and assembly line. And the big, I taught this actually in an engineering class a couple of years ago. The key thing with Henry Ford and the whole assembly line was really not so much the assembly line, but the idea of interchangeable parts. Yeah. Meaning, I could have a bucket of part A and a bucket full of part B, and I can pick any random part out of bucket A and any random piece out of bucket B, and they go together again. They go together. That's very different from the way things were made way back when, where if you had a machine or a device or whatever, that's the assembly of, let's say, 6 or 10 different pieces. They were machined to go together with each other. And so if I made 2 of them, I couldn't take the piece off of one and put it on the other, because each one was custom made so all the pieces fit together, which is basically a guy sitting there and whittling and filing away to get them to custom fit together. And so, yeah, I mean, again, just to get a little flavor of it, again, if you go on YouTube and look up Click Spring, and then he's got a whole bunch of different videos, but a lot of them on the Antikythera. And as I said, he tries to, even going so far as there's some videos I saw where he was making his own file, using, some, ancient techniques. But he, in his videos, really tried hard to make the mechanism using technologies that were available at the time that this device was made. So again, for if your interest is piqued, that's a great resource to look into, because he does a great job with his videos. I think he's Australian, if I'm not mistaken. So
That'd be great if you could send those links and that.
Yeah.
Spring.
Yeah, Click Spring. Yeah, I'll shoot some notes out to the club. Thanks for the question, Sheila.
Thank you, Jeff.
Yeah. Any other questions or comments? Okay. As always, keep an eye on the groups.io. There will be announcements between now and otherwise the next meeting in March. And finally, as usual, want to give a big thanks to Diana, who has provided refreshments. And she went above and beyond in providing refreshments without even coming out tonight. So thanks, Diana, and thanks for Greg for bringing the refreshments. So again, thanks for everyone for coming. Please join us for refreshments in the library.